This video is going to talk through graphing a parabola, just the basic points needed in an Algebra 1 course. And the formulas that you're going to need the formula for the vertex of the parabola, and we've already discussed that in previous videos, but keep the formula close. And then the axis of symmetry, noticing that negative b over 2a serves two purposes here. And then factoring, roots, zeros, quadratic formula, you're going to need to have all these skills handy. So let's analyze. I'm actually using page 9 in your notes, and I'm just going to analyze a few of the key points. We're going to plot the points, connect those up to create the curve. I'll do the 3 problems on this page, and that should be enough. That should be sufficient practice for you all to take it from here. So the first thing that's noted here, well, the first thing I would like to notice about this, the lead coefficient here is -1. So a is -1, which means that this curve is going to turn down. Let's see, identifying my roots or my zeros. When the lead coefficient is negative, let's see, the top of the big X would get the product of A and C, so that's going to be -5, and then the linear term is -4, so I'm going to go with -5 and +1 as my factors, and it just so happens that when the lead coefficient is negative, the numbers that occur in the big X right here, the factors that you choose, actually end up being the roots. So that's a nice little trait to take away from this. So here are my roots. They are -5 and +1, and we can explore that in Math Lab if you're interested, or you can just take my word for it that when the lead coefficient's negative and you identify the factors, you've got your roots and you're done. So as I said, this turns down, which means that the vertex is going to sit at the top, making it a maximum point or a maximum value. The axis of symmetry, I'm not going to waste time calculating a formula on a video. You all can do that on your own. B is -4 and A is -1. So when I evaluate that in my formula, I'm going to end up with -2. So the axis of symmetry is the equation of the vertical line x equals -2. The vertex has an x coordinate of -2, and to find the y partner, I would simply take, I'm going to calculate f of -2, which means that I'm going to go back to my original quadratic, and I'm going to let x take on the value of -2, and I'm going to end up with a +9. So I've got my roots, I've got my vertex, my axis of symmetry. The y-intercept occurs when x is 0. So if I go back to my function and I let x become 0, the only number left standing is my constant. A y-intercept is a point that sits on the y-axis, and the defining trait would be that the x-coordinate is 0. And then we'll analyze the symmetric partner when we plot the points. The domain for Algebra 1, for what we're doing, the domain will be all real numbers. And the range is going to be directly related to the y-coordinate of the vertex. So let me go ahead and plot the points, and then we'll pop in the correct inequality symbol once we analyze the graph. So I'm going to go ahead and plot my roots first, and I'll make the graph a little bit larger. So I'm going to plot -5 and +1. So here's +1, and here's -5. My vertex is -2, +9. And I'm going to cross the y-axis at +5. So let me sketch in the axis of symmetry. It's just the vertical line that puts the shape into 2 equal halves. And then let me go ahead and roughly sketch in a curve. And I'm going to connect up. I'll just do half of the curve. And it's a curve, it's not a sharp peak. Let's discuss the symmetric partner for the y-intercept. So notice here, I'll get a different pen color. Notice that the y-intercept is 2 units away from this axis of symmetry, which means that his symmetric partner would be 2 units on the other side. So his symmetric partner is going to be the ordered pair -4, +5. And it's just a visual common sense, kind of a, just a visual common sense point. And let me go ahead and finish my curve and try to make it a curve and not a sharp peak. Now let's analyze what we just did. And let me zoom the camera out and analyze what we just did. So we have our points, we have our roots or zeros. Those will be the spots where it would cross the x-axis. And since the lead coefficient is negative, that means that the curve is turning down. That means that the vertex is considered a maximum at the top. The vertex, we have a formula for calculating the vertex. It's the ordered pair -2, +9. The axis of symmetry is the vertical line that splits the curve into 2 equal halves, and it runs right through that vertex point. Points occur in a parabola in pairs, and they're symmetrically placed on either side of this axis of symmetry. So the y-intercept would be, it's the point that occurs when x is 0, so it's always going to be just the constant in the equation. And so for this particular equation, it's +5. And then the y-intercept is 2 units to the right of the axis of symmetry, which means his symmetric partner would be 2 units to the left. And that would just end up with the point -4, +5. Let's discuss the range. So here my vertex is sitting at the top, which means that this y-coordinate is the greatest y-coordinate on this curve. So that means that all of the other y-coordinates that occur in any point on this curve, all of those y-coordinates are going to be less than or equal to 9. So that's going to occur when I have a maximum. And the maximum value of the function is actually going to be the y-coordinate of the vertex. So the maximum value of this function would be y equals 9, and the vertex represents a maximum point on the curve. Let's do number 15. So number 15 is the perfect square trinomial pattern. And for this, my lead coefficient is +1, so that means that this curve is going to open upward. It's going to be concave up. I'm looking for factors of 9 that sum to 6. It's going to give me 3 and 3. And if I were to factor this, that would factor as x plus 3 squared equaling 0. If I multiplied that out, this is what it's going to generate. If I set this factor equal to 0, I'm going to have one root, and it's going to be -3. And this is a case that we would consider having a double root, because the factor of, it's a double root, because the factor of x plus 3 occurs twice. It's the same factor occurring twice. So you consider this a double root. If you were to calculate the vertex and the axis of symmetry using your little formula, you're going to end up with -3 once again. So the axis of symmetry is the vertical line x equals -3, and the vertex is the ordered pair -3, 0. So the trait that comes along with the perfect square trinomial, its root and vertex are the same. It has one root sitting right on the x-axis, and the vertex also sits on the x-axis. So the root and the vertex are the same. And let's go ahead and plot that point, x equaling -3 on the x-axis. So this represents my root and my vertex. The y-intercept for this particular sketch is going to be the point 0.9. So I'm going to go ahead and plot the y-intercept. I'm going to go ahead and sketch in my axis of symmetry. So there's my axis of symmetry. I've got my y-intercept plotted. I have my root vertex plotted, and I notice that my the y-intercept is 3 units to the right, so his partner is going to be 3 units to the left, putting me at -6, +9. Noticing that they have the same y-coordinates but different x-coordinates. Now max min, let me go ahead and sketch this in, and I'll try to make this a curve and not a sharp peak. Let's see, so I can see that my vertex is sitting down here at the bottom, so that means that my vertex represents a minimum point. The minimum value, if I were asked to find the minimum value of the function, the minimum value of the function would be y equaling 0. So the value would be directly related to the y-coordinate of the vertex, and you would consider the vertex a minimum point on this graph. Domain and range. Domain would be all real numbers, so you can just say all reals. And then the range, I'm going to compare y to the y-coordinate of the vertex, And when I look at this, I see this is sitting at the very bottom, a minimum point, which means all of the other y coordinates that would sit on this curve are going to be greater than or equal to 0. So I've done everything I need to do in an Algebra 1 course to plot some key points and just identify a few key traits. Let's do one more on the video, and I think that'll be sufficient practice for you. So this is number 16. And number 16, once again, I have that negative lead coefficient. And my lead coefficient is -1. So that's noteworthy. A is -1. So that means that this curve is going to turn down. And that means also when I set up my big X, -1 times +3. And I'm looking at -3 and +1. They're actually going to end up being my roots. And so my roots are zeros. And I didn't type this on your sheet, but I'm giving you this information so that you can do the other problems. So my roots are going to be -3, +1 inside the braces, not the smooth curves. The axis of symmetry, once again, you're going to need to get your formula sheet out and number crunch that. B is -2, A is -1, and that's going to result in an x coordinate of -1. So the axis of symmetry is the vertical line, x equals -1, and the vertex is the point -1. And then to find the y partner, I would evaluate my function for x equaling -1, and that's going to result in +4. So that's my vertex. And let's plot some of our key points and see what we've got. So my roots are -3 and +1. And my vertex is going to sit right in the middle. So that's going to be -1, +4. Here's my vertex. The y-intercept, looking at my function, if x is 0, the only number left standing would be the constant, or 3. So my y-intercept is +3. And I'm going to roughly sketch in my axis of symmetry. Well, I didn't do a very good job of that, but that's okay. My axis of symmetry is sitting right there. And let me get my page straightened up again. And let's see, my y-intercept is 1 unit to the right of the axis of symmetry, which means his partner is going to be 1 unit to the left. So his partner is going to be the ordered pair -2, +3. Let me move my paper over here. So my y-intercept is the point 0, 3, and his partner, even though I didn't give you a space for it, but if you had to identify it, his partner is -2, +3. And my curve, let me draw my curve in. So when I connect up my key critical points here, when I draw my curve, it's clear, easy to see that my vertex sits at the very top, making it a maximum point. So my vertex represents a maximum point. And my domain would be all real numbers. And my range, I'm going to compare y, and I've got my y coordinate of my vertex. Since this is sitting at the top, all of the other y values are going to be less than or equal to 4. And if I had to claim a maximum value for this function, the maximum value would be y equaling 4, the y coordinate of the vertex. So I think that's sufficient practice for you all to get through enough, just graphing for Algebra 1 purposes. And I'm going to end the video here. I think that's sufficient practice.